Hello, let's continue our Sudoku adventure with What Did You Say by PjoeterBliep. So, we have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have counting circles in the grid, that's these circles here. A digit in a circle indicates exactly how many circles contain that digit. So only if a digit appears in the circle. So for example, if this was a 2, then that means that there are exactly 2 2s in all the circles. So I could put another 2 here. That would fulfill it. If I tried to put a 2 here, now I'd have 3 2s. That is not exactly 2. If I tried to omit a 2 and I just have this single 2, that would be 1 2. That's not exactly 2. So we need 2 2s. And then this could be, say, a 4, and then the rest of them would be 4, which obviously doesn't work because these two conflict. But that is the idea. So that is counting circles. And then we have these red lines, which are noisy telephone lines. So adjacent digits along the line must have a difference strictly smaller than n, the noisiness. Now n is equal to the digit in the connected circle. So for example, if there was a 3 in this circle, and this was a 1, then these two digits have to have a difference of at most 3. So this could be, say, a difference strictly smaller than 3, not at most 3, so at most 2. So this could be a 1, 2, or 3. If this was a 4, 4 minus 1 is 3. That is not strictly smaller than this 3, so that's no good. So this is actually a valid way to fill this line, because notice that these two do share that line as well. So these two also have to have that difference that is strictly smaller than the digit in the circle. All right, which means if we put a 1 in a circle, then these would all just be 1s, because these two would have a difference of 0 and these two would have a difference of 0. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, so the first thing to do with counting circles is to count them, literally. There are 6 circles in the grid. So why are we counting them? Well, we know that the unique digits in the circles will sum to 6. Now, why is that? Well, whenever I use a digit like a 2, that's going to use up 2 of my circles. And I have 4 circles left. So notice by putting a 2 into the circles, I've subtracted 2 from the number of circles remaining. And then if I use, say, a 3 in the circles, then I have used up 3 more circles. So I've subtracted 3 from that total. And then I'm left with 1 circle, which would have to be a 1. And so we end up with 1, 2, 3, and those are going to sum to 6. So our options are to do 1, 2, 3. That's one option, which I just showed one way to fill that. Another option is to have 2 unique values. We can't use 6 though, because 6 would repeat here, and here, and a few other places. Now, but we could do 1, 5, or we could do 2, 4. So what do we want to do about that? Let's think about this line here. This line screaming for attention, because these are all unique digits. Now we could even do something like, I don't know, like a 2. Actually, how would this work? Obviously, this isn't a 1, because if it was a 1, these would all be 1s. If it was a 2, then I just need to have a difference of at most 1. So I think I'd have to go upwards. I think I'd have to go 3, 4, 5. So if I tried to go down, I can't jump past the 2 to 3. This would have a difference of 2, which is not allowed. So I'd have to go 2, 3, 4, 5. That would be an option. If this was a 3, then I could go down to 2 and then go up to 4, and that would be okay. So yeah, this actually isn't all that restrictive now that I think about it. It's just not a 1. Okay, so how many circles aren't a 1? This circle's not a 1. Let's just gray it. This circle's not a 1. This circle's not a 1. And this circle's not a 1. This circle is also not a 1 for an interesting reason, little bit different reason. If this was a 1, it forces this to be a 2. The 2 would always be next to the 1. Oh, sorry. Sorry. I was thinking about that wrong. This would be 1 and 1. That's okay, but this would then be 1 and 1, and that's not okay for the exact same reason we've been talking about. So if any of the circles are 1, it's this one, and we go 1, 1, 1 like that, which is possible because we only need 1, 1. But if there is a 1, it's exactly right here. Now, I haven't proven we have to have a 1, though. Because we could do 2, 4. It's the only way to avoid having a 1 is 2, 4. So I wonder if 4 is not possible, or 2. I don't know. 4 seems okay, right? Because the bigger the digit is in the circle, the less restrictive it is. And can I have 4 4s? I guess that's the next question. No, the answer is no. Okay. The reason is I can cover all of my circles using 3 rows. Which means within 3 rows, there are only 3 4s available. And so I can't place 4 4s in the circles because I'd be forced to repeat 1 in a row. No matter how I try to do it, I can fill 3 4s easily, but then the 4th 4 is always going to be in the same row as a 4 I already placed. So we can't do 2 4, meaning we must have a 1, meaning this is our 1, and we get 1 1 1 there. Okay. So we could have, okay, and we definitely can't have 5 in all of these because we couldn't have 4. We definitely can't have 5, which means we are a 1 2 3. So these are from 2 3 only, and that does restrict our differences quite a bit. Now, all of these have a non-repeat on the digit next to the circle, except for here. But here it does. And so when we put a 2, we'd have to put a 1 or a 3 next to it because that's a difference of at most 1. So we have to go consecutively along the line with a 2 on it. So next to the 2 is always going to be either a 1 or a 3. You'll notice that here, that means that one of these is a 3 at least. Because if both of these were a 2, wait, is that true? No, I could do 1 3. No, that works. Okay, so let's look at the columns and the rows. Okay, let's look at the rows actually. Here we go. Okay, this has to be a 3. Why? Because we need 3 3s. And remember, there were only 3 rows. So every row has to give a 3 to a circle. And so this row has to give it to this guy. That's a 3. That makes that a 2 and that a 3. Now next to the 2, remember it had to be 1 or 3. This already can't be a 1. So that's 3, making that the last 2 and that the last 3. Okay, perfect. 2 has to have a 1 or... Ooh. No, I broke it. This can't be 1 or 3. I don't know what my logic... What was my leap of logic there? My issue here is that this has to be 1 different from the 2. It can't be 0 different. But 1 and 3 are gone. Okay, what did I do wrong? Let's think about this again. Pretty sure the 1 1 1 was right. We can't put a 1 in any of these because we can't repeat the 1 next to it. So the 1 ends up here. And we can't do 2, and their biggest digit in the circles is 3 in general. So that's all proven. That's all correct. This does force 1 1 1 because it's difference of 0. They're all equal. The rest are 2 3. Now every row must give a 3. So this must be 3, making this must be 2, and this must be 3. And now, why did I make this a 2? I think I proved it can't be. Oh, because I needed this to be... Oh, this can repeat the 2. That's what I messed up. Okay. This does not... So these have to be... This has to be a 1 or a 3, but this can be a 2. This is a 2 or a 3. 2 3 pair does give us the 1 here. But also, we know this can't be a 2 because this can't be a 1 or a 3. So this must be 3, that must be 2. That's the mistake I made. Okay. That's 3, that's 2. Now, so these have to have a difference of 1. So we have to go 3 4 5. This is our 6. Up here we need 5 and 6. And then down here we need the 4. Now, next to the 3, what are we doing? Can't do 1 because there's already 1. Can't do 2, can't do 3. So this is either 4 or 5 in order to not be 3 or more different. Same thing here. This can't be 1, 2, 3. Oh yeah, this can't be a 6. That's the point. The column needs a 6. This is the other 4 5. These two 1s look up. This 1 looks in, placing the 1 in this box. And so that leaves a 2 6 behind. This 2 tells us the order. That's 6, that's 2, that's 5, that's 6. This is a 3 5 pair. We know the order. This is our 4, 3 in the corner celebrating. This is, this could be a, let's see, actually, this is from 2 5 6. Not a 6 for multiple reasons, but both 2 and 5 seem okay. This is from 1, 4. We know the order. That's 4, that's 1. Okay. Need a 6 here. That gives us 5, 2, and 6. So this is not a 4. So this is 5, 4, and 5. And then these are 2, 3, 4. The 2 goes here. 3 goes here. The 4 goes there. Nice. Cool puzzle, PjoeterBliep. That took some thinking. And unfortunately, it was easy to forget that I could repeat the digit across here. And so I forced it to be a 3, and that broke everything. But it taught me something at least. And I was able to backtrack and fix that. Cool. Very nice puzzle. I enjoyed that quite a bit. Let me know how you did. And if you enjoyed it, why not leave a like, subscribe, and a kind comment below.